Welcome to the lesson on modules. In this lesson, we will explore why and how software is organized. We will also look at some examples and learn some new functions on the way. Imagine a book library that looks like this, and a reader who wants to find the third volume of The Art of Computer Programming by Donald Knuth. How much of a chance would you give them? Software projects can span hundreds of thousands or even millions of lines of code. If the code is disorganized, finding relevant pieces can be just as daunting as locating a specific book in such a chaotic library. This is why all modern programming languages provide mechanisms for organizing code, making it easier to manage, understand, and reuse. In many languages, including Python, one high-level way to organize code is by dividing it into modules. Think of modules as the wings of a large library, such as the technical library and the medical library in the illustration. Just as our reader could easily locate a book about the art of programming in the technical library wing, we use modules to group related code, making it easier to find and use. Incidentally, a collection of related modules is called a library. One library every programmer using a programming language needs to know about is the standard library. This is a collection of tools provided with the compiler and prescribed by the language specification. In Python, the standard library is especially rich, containing hundreds of modules. This is why people often say Python is batteries included. This is a good thing, because it allows you to perform a wide variety of tasks without needing a third-party library. The term third-party means that it is neither in the standard library nor created by your team or organization. The standard library of a language is a good place to look for the best practices for that language. Hence, in organizing functions into modules, the Python standard library sets an example. The main idea behind the standard library and libraries in general is software reuse. For example, if you need your application to read data from a database, it's safe to assume that many other applications require this functionality as well. Hence, such functionality is likely to exist either in the standard library or a third-party library. Implementing it yourself would be reinventing the wheel. While reinventing the wheel might be beneficial for learning purposes, avoid doing so in production code. Beyond saving time, the level of optimization and testing in the standard library and other widely used libraries is hard to match. Thanks to a large user base, bugs in these libraries are quickly discovered and fixed. Therefore, develop the skill to intuit when functionality is likely available in a library and learn how to search for it. For complete transparency, there is a notable exception to this rule, but you don't need to worry about it at this point. While we are on the topic of organizing software, modules are not the only way to organize your code. Just as each library wing is organized into floors, halls, shelves, and so forth, there are also ways to organize code within a module. A function is one such way. For example, the log function in the math module of the standard library contains all the lines of code necessary to compute a logarithm. The principle to take from this is that it is essential to make good use of the tools for organizing code provided by the programming language you're using. In order to use the names defined in a module, we have to first import it. Here, I imported the math module of the standard library. And to call the function log defined in this module, I precede its name by the name of the module followed by dot. In contrast, the functions pow and round that we saw previously are built into the language. As an exercise in learning, please find out on your own the functions needed to perform the shown computations. Now, I want to show you how to use imports effectively and what to avoid. This expression computes the binomial coefficient 10 choose 3. You don't need to know what a binomial coefficient is to notice that this expression is bulky. When specifying the module name before each function call makes your code hard to read, as in this case, you can directly import the needed functions. You can also specify several functions separated by commas. Optionally, you can even assign an alias to a function. In this example, I use this to give the factorial function a shorter name. The set of names defined at any given point in the program is called the namespace. In our example, after the import, the built-in functions such as pow and round and fact are in the namespace. When a name already exists in the namespace and you introduce the same name with a different meaning, a name clash results. For example, if we import the pow function from the math module, it will clash with the built-in pow function. By the way, I hope the existence of another pow function makes you raise a brow. If it does, you know what to do, don't you? Having too many names in the namespace increases the likelihood of a name clash. This situation is called name pollution. A name clash may result in unexpected behavior of your program and difficult to locate logic errors because what the program does is no longer transparent. Hence, namespace pollution is something to avoid. This is why the next option is suitable only for quick experimentation, not for production code. Namely, you can include all the names defined in a module into the current namespace using the wildcard notation. A wildcard is a pattern that can match more than one thing. In our case, the star is the wildcard, and it matches all the names defined in the module. Here is a fun learning exercise. After performing the wildcard import as shown, try to call help pow and see what it outputs. You should notice something that seems to contradict what we've learned. When you do, take the time to explore it further. In summary, we have explored how much of a difference organizing software can make. We have also seen two ways of organizing code in Python: modules and functions. Looked at an example of how Python standard library organizes code, and learned several ways to import functions from modules. You have also learned quite a few terms. Lastly, and most importantly, you have learned principles that, once internalized, will help you write great code.